Hello everyone, this is Prasanna Patil, working as assistant professor in the Department of Computer Science, MIT Mysore. uh, now we are into second lab program, that is candidate oops, that is candidate elimination algorithm. Uh, let's read the program. For a given set of training data samples stored in a CSV file, implement and demonstrate the algorithm, candidate elimination algorithm, to output a description of set of all hypotheses consistent with the training examples. So this is also sounds similar to the first lab program, but how it is different. This is candidate elimination, that is find-S algorithm. Find-S algorithm, its output is a single hypothesis, right? Its output is a single hypothesis, but find-S algorithm's output is a single hypothesis, but candidate elimination's candidate elimination algorithm's output is a set of hypotheses. Set of hypothesis means it won't give you the specific one, but it will give multiple hypotheses. What do you mean by multiple hypotheses? It gives the boundary of hypothesis. That means the hypothesis will not leave this boundary, will not leave the lower boundary, will not leave this upper boundary. Okay, but the hypothesis will lies in between this specified boundary. It gives you the boundary. For the next training example, your hypothesis lies in between these two boundaries. It will not go beyond these two. What are the boundary? We name the boundaries as general hypothesis and specific hypothesis. We name the boundary as one boundary as general, one boundary as specific. Okay, what we do here exactly, we just initialize the specific hypothesis in the beginning, and we just initialize the general hypothesis in the beginning. As we read the data samples, we make the general hypothesis specific, and we make the specific hypothesis a little generic. So specific is moving towards general and general is moving towards specific. That's why we are making a boundary now narrower as we read the data samples. So this is what the candidate elimination algorithm is. Okay, and here also we read CSV file, and that's it. This is what the difference between find-S and the candidate elimination algorithm. And set of hypothesis, what we call is a version space. Okay, version space is a set of hypothesis where it has a boundary, general hypothesis boundary, and a specific hypothesis boundary. And how do we find the version space? We look into the algorithm, and then we understand what is candidate elimination algorithm. So as I said, these are the G for general hypothesis, maximally general hypothesis, S for maximally specific hypothesis. So we are setting the boundaries. So that is what initialization, from where to start the algorithm. And we already know that a general hypothesis is question mark, question mark, the number of attributes, question marks will be the number of attributes. How many number of attributes we have, those many number of question marks we have in the hypothesis. Okay, there is no change in it, but only change here is the dimension of hypothesis, that I'll discuss it while I execute the program, when I discuss the program. Okay, the dimension of general hypothesis and the dimension of specific hypothesis. Okay, and S is maximally specific hypothesis, that is null. We all know this before, depending on the number of attributes, number of null values. And also we know this, that this is one case, and this is another case. There are two cases here. One is the positive case, second one is negative case. One more difference we just gone through. The finders takes only the positive, but candidate elimination takes positive as well as negative. The candidate elimination algorithm works on the principle of if then eliminate principle. Okay, you might be knowing that principle, if then eliminate. Okay, what happens when the candidate elimination reads the positive, and what happens when the candidate elimination reads the negative? If we look into this with the help of algorithm, that makes sense. I mean, that will be easier to understand the algorithm. That way is the best way to understand the algorithm when we look into the example step by step. We are taking the same data set, 1 2 3 positive and 1 negative, the same data set. lab 1 and lab 2, the input is the same data set. Now we need to initialize the boundaries. How we are initializing? The upper boundaries, specific, and the lower boundary is general. And how we are initializing? We are initializing null s naught 0. S0 means 0 means before reading any data set, any data sample from the data set, right? Before reading any data sample from the data set, this is the initial specific and the general boundaries. And one second. This is after reading the first data sample. After reading the first data, what is the first data sample? This one. After reading the first data sample, since it is S, what we are doing, we are changing the hypothesis, that is specific. Okay, we are changing the specific hypothesis to S1. So whenever we read the positive example, as there are two cases, one is positive, one is negative. Whenever we read a positive example, we change the specific hypothesis as well as the negative hypothesis. Okay, we change the specific hypothesis as well as the negative hypothesis. Clear? Here since it is question mark and we left, since we have changed this to this and this to this, everything is changed, and this is okay. I'll explain how this will be changed later while we read the second one. When we read the last one, we get to know what changes we can make in general when we read the positive example, and how with the help of this. Okay, the fourth data sample. Now we read the second data sample. Okay, so everything was null, and while reading the first data sample, this became the first data sample itself. Everything is similar to over here. And when we read the second data sample, which is positive, we only change the specific as well as the general, but here it is not reflecting. I'll explain in the fourth, but I need to explain the specific hypothesis. So sunny and this sunny, no change. Warm and warm, no change. Normal and high, I need to change, question mark. So from normal to I change to question mark. So strong, no change. Warm, no change. Same, no change. So this is how a specific hypothesis, this is similar to the finders, right? The specific part is similar to the finders, but not the generic part. When we read the positive example, changing the specific part is similar to finders, but when we read the positive example, I need to change the general hypothesis as well. Okay, now we'll move to the next. Yes, the same explanation is done here, and this will not change. G1 and G2 will not change because both are positive examples. Okay, we have read positive examples. Now we have read two positive examples. I need to read the third negative example. So S0, S1 is over, and S2 is also over. Clear? After reading this third negative example, I need to only make change to my general hypothesis. Okay, I should not change the specific hypothesis. I need to keep it as it is. That's why I have written here S2 and S3, because it will be similar. Okay, then I need to make changes to my general hypothesis. So how do I make change to my general hypothesis? So this is a case of negative. I need to change. How? I need to compare this specific hypothesis with the present instance. If both are not similar, if both are different, then what will happen? If both are different, then what will happen? I meant when the sky is cloudy, it is leading to negative. Means no, when the sky is sunny, it is leading to positive, because it is a specific hypothesis. This takes only positive, right? When the sky is sunny, it is leading to, the outcome is positive, that is yes. When the sky is cloudy, it is leading to negative. That means what? I can generally say that when there is sun, then there is a positive. When the sky is sunny, then that leads to positive, irrespective of other 5 attribute values. That means when both are different, I need to make this value over here. Is that clear? Keeping other attribute values, question mark. Oh, we'll move to the next one. Warm and cold, both are different. That's why what I did, I made this value over here, keeping all other values, question mark. Okay, this is same as, the explanation is similar to the previous one. Now question mark is similar to high? No, both are different. That's why I need to keep over here the same over here, means keeping all other 1 2 3 4 5 6. So what I did here, I replaced this question mark with this question mark, that's it. And what I did here, prior it was, this is G2. I'll explain this. What is the dimension of this G2? This is 6 cross 6. 6 cross 6 means in a list it has 1, 2 up to 6. Okay. And what I did, I just changed this Sunny from the here. I just changed the Sunny, and everything is question mark, and I from second I changed warm here, and everything else is question mark, question mark. The third one is I'm again doing the same, question mark, nowhere else I'm replacing the value from the question mark. So that's why they have not written here question mark, because question mark, no need to write it. Next is strong. I'm comparing strong with strong. Both are same. If both are same, replace it with question mark. Replace this strong with, in the sense, if both the values from the specific and the data sample in the general hypothesis, keep question mark. Okay, over here, question mark. Next is warm, and warm again do the same, question mark. Same with change. Now what I need to do, I need to replace the question mark from the last, that is question mark 1 2 3 4 5 with this value with same. That is why I have written over here. I hope you understood. Go through it carefully, you'll get to know. So I'm done with the third one. Now we'll move to the fourth one. 1 is over, 2 is over, 3 is over, and the fourth one is S. Now this is one more important step. What happens when, and what exactly, which value exactly, or which hypothesis exactly we update, we will get to know in this step. S3 was the old specific hypothesis, and G3 was old specific hypothesis before reading this fourth data sample. Now after reading this fourth data sample, since it is S, what I need to do, I need to change my specific as well as the general hypothesis. How? See here. Sunny is same as Sunny, then keep, no need to change, okay, no need to change. Warm is similar to warm, no need to change. Now question mark is different than high. What I need to do now, question mark, keep this question mark as it is, and high, don't do anything. Keep this question mark as it is and don't do anything. Now strong is same as strong, don't do anything. Now warm is not same as cool. One more thing, this question mark will be here. I need to change it with question mark. Okay. Now warm with cool, both are different. So what I'm doing, I am changing the value of a specific to question mark, right? Once I change the value of this to specific, what I need to do, I need to change the value of this particular attribute in the general also. I need to change the value of this particular attribute value belong to water, right? Water means it is a fifth position, and this is sixth position. 1 2 3 4, and I was telling you regarding the dimensions, right? 4, 5 and the 6th. This is done, already done. Okay, we are reading the fifth one. So this was what is the value of this prior. This was sunny, this was warm, right? This was sunny, this was warm, and question mark everywhere, question mark everywhere, question mark, and here also everywhere question mark, and here we had same. Right? Okay. And if both are different, warm and cool, and we change the specific hypothesis to question mark, also we need to change the general hypothesis to question mark. If we had anything before here, I need to change it to question mark. Since it is question mark before, no need to change, means even if we change till it looks the same. Clear? 1 2 3 4 5 6. Now moving to the last one, same and change, both are different, that's why I need to change my specific value to question mark, and also I need to change my general hypothesis to question mark. This belong to 6th position, I need to change the 6th position value, so that's why I'm not including this in my new general hypothesis. Right? I had 3 hypotheses in the general, and after reading this fourth data sample, I just made it more general than this, more specific than this. This is general hypothesis, right? I'm moving from general to specific, and from above I'm moving from specific to general. So now I have 2 hypotheses. Prior I had 3 hypotheses. So this is the, I can say that this hypothesis is more specific than this hypothesis. So after reading all the 4 examples, data sample, so what I can say is these 2 hypotheses are the boundaries for general and the specific hypothesis. This is specific hypothesis boundary, this is general hypothesis boundary. Okay, boundary, not a single hypothesis we got here. And how to find the version space? Whatever I have got from S4 and G4, I have written over here. And this is one hypothesis, second hypothesis, this is a specific hypothesis. And how to write the version space? Just remember, in this general hypothesis we have only one attribute value among all the 6 values. Here also this is the second hypothesis where I have only one hypothesis among all the 6 attribute values, and this is a specific hypothesis where I have 1 2 3 values among 6 attribute values, right? But I should find a hypothesis in between these two. This is 3, this is 1. I should find a hypothesis having 2 attribute values, right? So how? I need to take one from this and one from this, 2 from this. So I took sunny over here and one more from this, strong from here. I took sunny from here, I took warm from here. Okay, right? Since I have sunny, I cannot take the third value, right? So I took the warm from here and I took the sunny from here. I took the warm from here, I took the strong from here. So I found this is 1 and this is second, this is third hypothesis. So everything what we say is the version space, and these 2 are the boundaries. Specific boundary, this is general boundary. So if I read the fifth data sample, now coming to the fifth data sample, if I read the fifth data sample, candidate elimination algorithm ensures us that the hypothesis should lie can be only these three. The hypothesis should lie in between the specific and the boundary. That means the hypothesis can be this or this or this. Means it lies in between 1, 2, 3, 4, 5, 6 hypotheses. So we have only 6 hypotheses when we read the next data sample. The hypothesis cannot be beyond these hypotheses. Okay, again it will give the boundary. Clear? So this is regarding the candidate elimination, and we look into the program. Similar what I explained. I'm reading this is reading a file, and this is converting into the means after reading, taking everything, and I have commented over here. What I commented over here, see, I just wrote this line. This line is combination of these two lines. When I read the file as an argument using csv.reader file, then I take this x, okay, and I use the same x value as a parameter argument for the list. And what I did, this is nothing but indexing list values. See here, and this data has everything from here to here. Okay, from here to here. X has, okay, list list of x means this is nothing but 0th index, 1 index, 2 index, 3 index, 4th index, correct? But when I am converting this x, x into list, everything will be indexed as 0, 1, 2, 3, 4. But I am transforming from which index? From first index, means I am skipping the attribute part. Clear? I am skipping the attribute part like this. In the earlier program, what I did data.pop of 0. You can do that also, but you can do this way also. So this is from first row to the last, means there is no end. How many data samples we have? That many rows. From first data sample excluding the 0th, 1, 2, 3, 4 will be stored in data. So data will be now like this. This is data. So now I say that this is data of 0, data of 1, data of 2, data of 3. Understood? Okay. These two are commented. Either you can use this or these two, anything, and I have noted here. Now what I need to know here, I need two things here. What I need the specific hypothesis and the general hypothesis. Okay. Most important thing in this second candidate elimination algorithm is the way we are programming is a little different. The way we programmed in first was different, and here also different. What is the difference? Okay. I am considering this is data, right? As I told, this is the whole thing is data. I am considering this as the target, and I'm considering this as my concept. Okay, I'm just copying it into a list object called concept, right? Concepts, and I'm copying this in targets or target. Okay, I'm copying everything, all the attribute values into concepts and all the labels in target. So how I did using for loop and taking the data, taking the data object into the for loop. Okay, this is accept the target value, and this is including the target value. So yeah, from 0 to -1 means from 0 to last except last element. 0 to except, if you specify with if you do not specify 0, that is understood, from first element to except last element, all the elements except last element. From, but here in target, what I'm doing, I'm taking only the last element, and since there is no colon here, I'm taking only one index, that is the last index. -1 means last index. This is -1 and this is -2, right? So I'm taking the concepts from 0, 1, 2, 3, 4, 5 except this -1. So that's why if you include -1, this value, this index will not be included. Okay, I hope you know this. And specific hypothesis, this is my specific hypothesis. Concept of 0, this is concept, right? Concept as 0. Why I took this as specific hypothesis? Because I already know that the outcome of the first hypothesis is S, right? That's why if you have taken this hypothesis as first hypothesis, then you cannot write this. Okay, you need to check whether the target of particular hypothesis is yes or no, then only you can do this. Since we just wrote a simple program for this, we have skipped that. We have directly taken the first example as a specific hypothesis, because we already know that it is a positive example. Okay, and coming to the general hypothesis is, as I already told, general hypothesis is not a single dimensional, it is a 6 cross 6. Okay, why it is 6 cross 6? Because we are only interested in changing the diagonal elements. We are not interested to change the other elements other than the diagonal elements. Next, and how I created a 6 cross 6 dimensional list object? Because how I just opened a square bracket and I closed the square bracket. Okay, and what I did, this is to create a list, right? This is the usually how we create a list. But how I create a multi-dimensional list? One more square bracket, and that should end over here. Okay, and this is one for loop, and this is second for loop. This is for row wise, and that is for column wise. Okay, I hope you know this. And all the values in the list will be replaced with question mark. This is my initialization of general hypothesis. And till now we got to know that specific hypothesis is single dimensional and general hypothesis is multi-dimensional, two-dimensional. Okay, two-dimensional, one for rows, one for columns, and the dimension is 6 cross 6. Now my uh, my logic is from here to here. uh, what is the logic? Logic has two cases, as we already know. It has a positive, reading the positive examples, and reading the negative examples. Okay, when we read the positive examples, again what we do, again we have to read a specific instance with the help of for loop. Again, when it is a negative example, again what we do, we just read the instance with the help of for loop. Correct? So one is outer for loop and one is inner for loop when it is positive, and another one is another also inner for loop when it is negative. Okay, when we are reading the positive example, what we have to change, we have to change the specific hypothesis as well as the general hypothesis. See, a specific hypothesis index is single, but the general hypothesis is two dimensional. This you should keep in mind. And whenever both are different, then only we are changing it to question mark. Whenever both are different andre the instance and the specific hypothesis what we have initialized, both are different, then only there is question mark, and general also there is question mark, as I told. Okay, this is about positive, and you know about the for loop. This is specific hypothesis length, and here also this is specific hypothesis length. When it is negative, what we are doing, we are changing only the general hypothesis. Here we are changing both specific and general in case of positive. In case of negative, only we are changing the general hypothesis, and you know that general hypothesis is two dimensional, x cross x, x cross x. Correct? This is the variable name or object name. Okay, general underscore h is a object name of a list object. Correct? And in negative, h of x is not equal to specific h of x. When both are not same, then only we are changing the general hypothesis to specific hypothesis. When both are not same andre illide ನೋಡಿ. When both are not same, as I told you in the example previously, before, when both are different, then only we are changing this. Correct? When both are different, then only we are changing this. Only diagonal elements. Correct, all those mostly I got the same, only two values, right? We got in the general hypothesis we got only these two. This is the first one, this is the second one. Correct? And all other are question mark, that's why we have not included anything. Correct? And how to remove this? I need to remove this. I don't need all these. I don't need the hypothesis having question mark. I need only to display, I want only to display the hypothesis with some values. So how to do this? I need to find these question marks from I need to find this question mark, this type of format from the general hypothesis, and then I need to eliminate this from the general hypothesis. Correct? Simple. So what I am doing, I am finding the indices. I am finding the indices where so here what are the indices? This is 0, this is 1, this is 2, 3, 4, 5. Okay, these are indices. So I need the indices values of those where I have question marks, only question marks. 1 2 3 4 5 6 6 question marks. 1 2 3 4 5 6 6 question marks. So in this line I am using enumerate. You know already what is enumerate function does. It returns two values. It returns two values. One is the index, second one is the value at the index. So these are two local variables in the for loop. I hope you are following me, because this is a repetition. I can't explain more. I for I val in enumerate general hypothesis. So general enumerator is returning two things, that is, one is what is the index of the first sample, or first see here, this is the first value in the general hypothesis. So in the first iteration, what enumerate is returning, the I value will be 0 and value will be Sunny and this. Okay. In the second iteration, the I value will be 1 and value will be this much. In third iteration, 2, this one. Fourth, this one. Okay. So it is just returning and it is taking, and it is checking whether after it returns whether we are just checking the value is question mark or not. If it is question mark, then get the index. That means indices, in what is the indices value? Indices is equal to, after we successfully run this line, indices will be 2 3 4 5. Correct? 2 3 4 5. Yes or no? Because all are question mark. That is what we wanted, right? We wanted to remove it, but before removing we need to know what is index of this. So we just found 2 3 4 5 are the indices, and in the next one we need to remove the value of this at this particular index. How do we remove? With the help of for loop. I in indices, I is a local variable, indices has 2 3 4 5. In the first iteration I has 2 and general hypothesis remove, so this will be removed, right? And we also know, okay, this is a specific hypothesis, this is general hypothesis. We know that we need to write a version space. This is the boundary, specific boundary, general boundary, and we need to write the version space. How do we write the version space? I just keep this Sunny over here, Sunny, and I just keep this strong. Strong is at 1 2 3 4th place. 1 2 3 4th place. I just write strong. 5th question mark. 5th question mark. I have only option to write. I have only option to fill only 2 values. 3 is already there. 1 is already there. Okay. Now Sunny, I just kept this. Sunny, then okay, I need to leave this now. Sunny with warm, then question mark, 4 question marks, 5th, 6th. What I did now, I just made this, wrote this over here, and also both are here, Sunny and warm are here, and warm, okay. And I need to write one more. What is it? I don't want Sunny over here, I want warm. So first value will be question mark, then second is warm, 2 are over. Next I need to write question mark, 4th place, 3rd place, 4th place, strong, question mark, right? So I wrote warm over here, that's why the arrow mark, and warm and strong both are here, this is arrow mark. So this was the candidate elimination version space, what we have just found. Now we'll execute the program and we'll wind up. Okay, before we go to the second lab program, we just run the first lab program. No. Okay, we just run it. Once I run, I got this. And 1 second, before, did you just observe that? Okay, I'll just clear it. Before I run this variable explorer, I had nothing in the variable explorer, and we have file explorer. This is to make sure that whenever you are using a CSV file, go to file explorer, and if you have the file anywhere, and you just browse that file, means change the directory. If I have anywhere over here, and I'll just change it, and I run this, this will run for sure. And help is to get the documentation of any of the module or any of the method. If I don't know what is reader method, I just need to click on reader, and then I need to click Control I got to know that here. See here, I need to press Control I. Okay, I got to know what is this reader about. And if you want to know a detailed description of the reader, that will be displayed in help. So if I don't know about any of the module CSV, see, I just click on this and I just press Control I. See, I got the information about this. Okay, whatever the documentation it has, it will display. Clear? And the same thing is not with the notepad. Sorry, Jupyter Notebook. You need to press over there shift plus tab to get the information of a particular module and the method, and the list of arguments also, what the method is taking, how many arguments, and with example also they have given here. Also they have given with example. Reader, if I click Control I got Control I, and okay, no, not detailed description of this reader is given here. But if you go in Jupyter Notebook and press shift tab, you'll get to know detailed description of each and every thing. I hope I have explained this before. Now we'll move to the candidate elimination. I just save it. I have saved and I run it. I found no such file or directory, because I have changed the file name. I need to change it to lab2.csv, right? Okay. I just save it, I run it. Okay, I got the output. This is the general hypothesis, and this is specific hypothesis. Okay, the same I got, right? Sunny, warm, question mark, strong, question mark, and general thing is sunny and warm, others are question mark. And in the variable explorer, I can find what are the different objects I have and what is the type. See here, I have different types of variables, objects, and type of it, and what is the size and what is stored inside it. So concept has, see here, I just if I double click, I get to know what is inside the concept. Okay, this is the index. In the index 0, 1 row, second row, third row, fourth row, and each row has 6 values. Okay, this is what the detailed data has here. Data has this much. Data has with the target, concept has without target, and target has only the targets. This is what the output. Thank you.